In this video, we're going to review everything we've learned about polynomials and multiplying them and adding them, etc. So here we go. In this first problem, we have a monomial times a monomial. 5 times negative 3 multiplying the coefficients gives us negative 15. Then when we multiply each of these variables, we add the exponents, and we're going to have x to the 6th and y to the 4th. Okay, the next problem. We know that anything to the 0 power is 1, but this exponent of 0 only applies to the x. So we're going to have 5 times 1 here, which makes 5. Number 3. A negative exponent says I get to be moved down to the denominator. So we get 1 over 3 to the 3rd, which becomes 1 over 27. In number 4, we're going to multiply exponents whenever we have a power to a power, and that will give us x to the 15th. Okay, now for one of these messier problems. We're going to simplify inside the parentheses first. 3 over 6 reduces to 1/2. I'm not going to write the 1, as you'll see why in a little bit. With the x to the 2nd, that negative exponent moves the x squared down to the denominator, and we add exponents and we get x to the 7th. With the y to the minus 2nd, those will move upstairs to the numerator, giving us y to the 6th. Notice now that I have something up in the numerator, I don't need the 1 in front. This is all being raised to the minus 3rd power. And it's a lot easier on these negative exponents if we only do the negative exponent part, not the 3, not the cube. Bringing that negative exponent in gives everything inside a negative exponent, which basically says everything inside gets to switch from numerator to denominator or vice versa. So the 2x to the 7th will come up to the numerator, and the y to the 6th will move down to the denominator, and this will all now be to just the positive 3rd power. Now we can do the cubing. 2 to the 3rd makes 8. And we're going to multiply each of these exponents to give us x to the 21st and y to the 18th. So now we've got another one of these problems, because I know my students always are asking for more of these. I suggest you pause the video right now and do it, and then turn it back on and check yourself. Okay, welcome back. Just kidding. Okay, we're going to reduce inside, and that's going to give us negative 1/2. I'm not going to write the 1. With these x's, let's take a look at what's happening right there. The x to the 7th moves to the numerator. The x to the 5th moves to the denominator. Then I see that I've got 2 extras up in the numerator, giving me x to the 2nd. I could have also said negative 5 minus the negative 7 gives me negative 5 plus 7, and gotten the 2 that way. With the y's, the y to the minus 3rd travels down to the denominator. The 4 plus 3 then becomes y to the 7th. And with the z's, the z to the minus 3rd goes up to the numerator and gives us z to the 4th up in the numerator. All of that is to the negative 4th power. And just as we did in the last problem, I'm going to distribute only the negative in, which has the net effect of flipping over that fraction. So we have 2y to the 7th in the numerator, and negative x squared z to the 4th down below, all raised to the 4th power. Now we apply that 4th power. 2 to the 4th is 16, and then we have y to the 28th, which we get when multiplying. A negative to an even power is positive, so we can ignore that negative. We're going to have x to the 8th upon multiplying, and z to the 16th upon multiplying. And that is our simplified solution. Turning the page, we now have some scientific notation. I see that we have a times 10 to the 4th, which means we have a larger number. And this 537 is already going to have the decimal move 2 digits to the right. We're going to move the decimal 2 more places to the right, attaching 2 more zeros, and we have 53,700. Going into scientific notation, I want one non-zero digit to the left of the decimal, or to the left of the decimal, giving me 3.65. And then how many places have we moved that decimal? 3, 6, 7, 8. So this will be times 10 to the 8th power.